program has been financed by LIFE, an EU program, and green funds. The partners of the program are the Technical University of Crete, which is the coordinator and has designed and manufactured the gasification system and the energy production. They are, which is a water and wastewater company of Rethymno, which hosts the whole system. Device, a company based in Athens, which has designed and manufactured the microsieve. Setenma, which has deals with energy and mass balances of the system and other technical issues. And Enginov, which is a UK-based company, which has designed and manufactured the dryer. The budget of the program is about 2 million euros, out of which 60% has been financed by the LIFE program and the rest by the partners. The capacity of the system is about 5,000 cubic meters per day in raw wastewater, which corresponds to about 1/3 of the wastewater enters the wastewater treatment plant of Rethymno. And this produces about 1/2 ton of biosolids on dry basis with energy value between 21 to 22 megajoule per kilogram, and produces about 10 to 15 kilowatt of energy, net energy, electric energy. The system operates like this. Raw wastewater enters the microsieve. The microsieve separates solids from the liquid. The solids, with concentration in solids about 45%, they go into the dryer, where with thermal energy from 45% we go to about 85 to 90% in solid content. And then this enters the gasifier, which gasifies the solids. They produce syngas, which contains carbon monoxide, hydrogen, carbon dioxide, and methane, basically, at a temperature about 700 to 800 degrees Celsius. Following treatment, the syngas enters the cogeneration engine, where it is combusted and produces electric energy, which we use to run the system, and thermal energy, which we use in the dryer to dry the solids from 45 to about 90% solid concentration. The liquid which exits the microsieve contains significantly less amount of solids, thus they consumes significantly less energy to treat this wastewater. We also have some ash production from the gasifier, which we manage accordingly. Here you can see the microsieve. This is the first microsieve which had been designed by our laboratory, and the microsieve is a device which separates the solids from the liquid in wastewater. This is the second microsieve which has been manufactured by device for the program, and this separates the solids. We take the solids with about concentration 45%, which is a very high concentration, and then we transport those into the dryer for further drying. Here we have a system where we weight the biosolids produced by the microsieve. We have also the option to mix those biosolids with secondary biosolids from the ER. So we have this silo here where we fill up with secondary biosolids, and then we mix in accurate quantities, and we enter these biosolids into the dryer for further processing in the gasification. Here we can see the dryer. The dryer receives the sludge from the microsieve. As we can see, the dryer composed out of 2 cylinders. Inside the cylinders we have screws which continuously agitate the sludge, and the dryer receives thermal energy from the generator which consumes syngas. The sludge inside the dryer goes up to about 85 to 90% solids, and then it goes into the briquetting machine and then into the gasifier. This is a gasifier, the heart of the system. The biosolids exiting the dryer, they enter into the briquetting machine, where we apply high pressure for the production of briquettes. The briquettes automatically enter the gasifier. Inside the gasifier, the briquettes are combusted under a controlled atmosphere with reduced oxygen, and we have a temperature there between 700 to 800 degrees Celsius. Inside the gasifier, we have anoxic conditions where it is produced syngas, which after treatment enters the cogeneration engine for the production of electric and thermal energy. Along with the syngas, some solid residue is also produced during the gasification process, which we collect and we treat accordingly. This is a syngas analyzer. We have manufactured this system where syngas goes through this tube. Here we have selective electrodes which measure the concentration of various gases, such as carbon monoxide, hydrogen, carbon dioxide, methane, and other composites of syngas. Following the production of syngas, it cools down, then enters into the filter, and then into the scrubber. After the scrubber, the syngas is ready for combustion. We combust this into a cogenerator, which produces thermal and electric energy. The electric energy we consume or we send to the grid, while the thermal energy enters inside the dryer through this tube. To carry out all the analysis, we have equipped this mobile laboratory where we do all the analysis in the wastewater. This is the control room of the pilot plant. Here with the PLC and the SCADA, we can monitor the various parameters of the system. We can monitor the concentration of syngas, the operation of various motors, the temperature, pressure. We can also control the various motors to switch on and switch off motors and anything else we need.